We've had access to the night sky for as long as we've been human, and watching patterns in the sky has been such an important part of human history. And suddenly the patterns in the sky are starting to be dominated by artificial satellites that humans have launched. We're changing the way the night sky looks for everyone, and we don't know what that means. So my goal is to tell people that the night sky is being changed, and it doesn't have to be.
Hi, I'm John Lajamodiere, and welcome to Go Far Together, a new podcast from the University of Regina that introduces you to some of our university's brightest thinkers. From outer space to reconciliation, from first responders' mental health to the connection between cannabis and the NFL, we'll explore how these researchers are changing the world and how we understand it, right here in the prairies. Join us as we go far together. Early each morning, while it's still dark, Assistant Professor and Observational Astronomer at the University of Regina, Dr. Samantha Lawler walks out of her home in Edenwald, about 30 kilometers north of Regina, and sees what humans have seen for centuries, an expanse of stars that inspires in us a sense of wonder, a sense of possibility.
Here in this remote stretch of Saskatchewan,
wow, that's a lot of stars.
A chance to see the brilliance of the night sky.
That's so cool.
But astronomer Samantha Lawler says it's changing and fast as more and more satellites get in the way.
This new light pollution is going to change the way we do astronomy and change the way the night sky looks for everyone in the world, because there's just so many more satellites being launched, and they're very bright.
Lawler's been watching from her farm as the number of active satellites has exploded from about 1,000 in 2017 to more than 5,000 today.
It's kind of terrifying how many you can see. Right here in Saskatchewan, we have such beautiful dark skies. We have a couple of the best dark sky preserves in the world, so this new satellite pollution is extremely visible.
There's one. I see a satellite right up there.
So when a satellite passes through, you get this bright streak of light that goes across your image. And so the Kuiper Belt objects that I'm trying to detect are millions of times fainter than the satellites that pass through the field of view. So it's very challenging.
We definitely lose images regularly due to satellites. There's data that is just so bad that it never makes it through our pipeline and we even see it. There's some borderline data that we do see where you see the moving object moving into a satellite trail and you can just sort of just pick it up.
Rosemary Pike is an astronomer at the Minor Planet Center at the Harvard and Smithsonian Center for Astrophysics and has worked on research projects with Samantha for over a decade. Like many astronomers, she's frustrated by satellites that frequently get in the way of capturing quality images from space.
The whole chip will saturate and we won't get any data off it at all. Sometimes it actually causes ghosting, and the next several images off the camera will still basically have ghosts of that trail.
In astronomy, ghosting refers to an effect on a camera image that's not caused by what is currently in the field of view.
Basically, you have lingering charge that has accumulated from something that happened in the past. So sometimes it has to do with issues with the amplifiers, but usually what you're seeing is lingering charge from overexposure in a previous frame.
Falcon 9 is in startup.
5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9.
While many companies are racing to send their satellites into space, according to the nonprofit satellite tracker Celestrak, nearly half of all active satellites are launched by Elon Musk's SpaceX. Many of these satellites are part of the company's Starlink project, an endeavor to spread broadband internet access into remote rural regions. But at what cost?
So SpaceX is doing something that is going beyond what we've known about our operations in low Earth orbit. So that is that they're just putting so many satellites up there and operating them as one single company, a number that we have seen in total in low Earth orbit prior to their launches. And this is an entirely new development.
Dr. Aaron Boley is a Canada Research Chair in Planetary Astronomy, Associate Professor at the University of British Columbia, and co-director of the Outer Space Institute, a network of researchers all united under the idea of the sustainable development of space. Samantha and Aaron have written 2 papers together on light pollution that have helped push the issue into the mainstream.
The paper, in fact, demonstrates that we have some of the worst light pollution from satellites in the world at this latitude.
It's not just astronomers worried about light pollution. The topic has received international attention, thanks in part to the hard work and advocacy of astronomers like Samantha. Here's NPR.
SpaceX plans to launch over 40,000 satellites, more than 10 times the number in the sky now. That worries some people who like the sky the way it is. Samantha Lawler is an astronomy professor at the University of Regina in Canada. She fears that advancing our connection to the internet could come at the expense of losing our connection to the stars.
She has been a major advocate for the protection of dark skies, and she's been very public about that. And that's through social media, that's through traditional media, and also with just talks around Canada and even throughout the world. So it's really important to have individuals like Sam to be able to go out and not just do the research, but connect with people.
I've been on almost every CBC show talking about it.
Samantha, just how busy is the night sky above Edenwold these days?
I've been on the radio in South Korea.
Let's speak with our expert for today, Samantha Lawler, who's an assistant professor of astronomy at the University of Regina.
And Dubai.
On Dubai Eye 103.8, the UAE's #1 talk radio station.
Satellite pollution is threatening to alter our view of the night sky. Now, that's the message from astronomers. Earlier on, I spoke to Professor Samantha Lawler. Now, she's
all over the world. So there's been a huge interest in this.
So who's ultimately responsible for our view of the sky? And what can be done as more and more companies begin sending their own satellites into space? Samantha has advocated for making the darkening of satellites a priority for SpaceX engineers. But any change is happening far too slowly.
The companies who are launching these satellites can do whatever they want. And they know that. So they're launching as fast as they can because any regulation has to be at the international level and it will be extremely slow to happen. So the only thing that can change what these companies are doing is public opinions.
Beyond simply protecting the view of the night sky, the practical implications for astronomy are huge. They can hamper important research that begins to answer questions about our very existence. These days, Samantha is interested in trying to figure those questions out. She's currently using powerful telescopes and computer clusters to study Kuiper Belt objects as they orbit around the outer edge of our solar system. But what is a Kuiper Belt object, and how can it help answer fundamental questions about the universe?
So these are icy bodies in the outer solar system that, for all intent and purpose, look like asteroids, only they're cold and a lot further out. So the boilerplate that you always give at a party is that, of course, Pluto, we know, is not a planet and is in fact one of those Kuiper Belt objects. And we could see that it was on its way to becoming a planet until that process got disrupted. And so what processes were those, and why did they happen, and when did they happen?
Dr. Wes Fraser is an astronomer working at the Dominion Astrophysical Observatory for the National Research Council of Canada. He's currently working with Samantha and Rosemary on a 2-year project called the COS Legacy Spectroscopic Survey, or CLASSY. The project aims to discover very faint and very distant Kuiper Belt objects all around the solar system using the Canada-France-Hawaii telescope, a tool astronomers use in a collaborative scientific effort to better understand the universe.
So there's thousands, probably hundreds of thousands of these small icy bodies out there. Currently, we know about 3,000 of them. I've mostly been using the Canada-France-Hawaii telescope to discover what I hope will be hundreds of new Kuiper Belt objects, and that will tell us about how our solar system came to be in the orbital configuration that we see it in today.
So in CLASSY, we've gone a different direction. We're going for depth instead of area. So we're taking about 3 hours of time and just taking image after image after image after image. And that allows us to stack to a much better depth. And it also makes us a bit more robust to issues like satellites because we can exclude single images if there's contamination.
Prior to Classy, Samantha worked on the Canadian-led Outer Solar Systems Origin Survey, or AUSIS, an astronomical observation program that involved 40 scientists from 8 different countries who worked to map out the distant solar systems beyond the 8 planets. Samantha is continuing work she started in that survey to test out the fascinating and somewhat provocative Planet 9 theory. The theory was first theorized in a 2016 paper by Caltech researchers Mike Brown and Konstantin Vatagen.
What we have discovered is that numerous features of the Kuiper Belt, a field of icy debris beyond the orbit of Neptune, can be understood if the solar system possesses an additional 9th planet that resides well beyond the orbits of the known planets.
Samantha happened to be an undergrad at Caltech when Brown first discovered Eris, the first Kuiper Belt object larger than Pluto. Now she has come full circle, investigating Planet 9's existence and the astronomers' conclusions.
So Planet 9 is a theoretical giant planet that would be in the outer reaches of our solar system, way farther away from the sun than any of the known planets. So Neptune orbits about 30 times farther away from the sun than the Earth does. Planet 9 would orbit about 500 times farther away from the sun than the Earth. So way out there. And it would be something like 10 times the mass of the Earth. So smaller than Neptune, but much bigger than the Earth. And this theory was proposed to explain the orbits of a few very distant Kuiper Belt objects that all were kind of pointed in the same direction. So the theory is that if there is this giant planet out there that we haven't discovered yet, then all of the most distant Kuiper Belt objects that we discover should all kind of be pointed in the same direction in the solar system because they're being sort of gravitationally kicked by this giant Planet 9. And if it doesn't exist, then there should be Kuiper Belt objects evenly spread around the solar system.
But Samantha thinks these conclusions may have come from observational biases.
It's really hard to find these things. They're really faint, they're really tiny, they move against the background stars. So it's really easy to just find the ones that are easiest to find. And it's entirely possible that they've all been found in the same direction just by chance, just by when people have telescope time and good weather and trying to avoid the Milky Way. But the large program that I am currently leading on the Canada-France-Hawaii telescope is going to look for very distant Kuiper Belt objects evenly around the solar system. So we should be able to answer this question of whether these very distant Kuiper Belt objects are clustered or not. And that will provide evidence for or against the Planet 9 theory.
Samantha Lawler's interest in the solar system began growing up in Southern California, her eyes gazing at the sky above.
I was interested in astronomy ever since I was very little because I was curious about who else is out there in the universe, what kind of planets they might live on. Lots of Star Wars and Star Trek definitely fed into that curiosity and pushed me on this path.
Live long and prosper.
These days, Samantha is less concerned about life on distant planets and more so on the life back at her farm.
I got dairy goats and I learned how to milk them, and I love it. I love being able to do all of this research and teaching and also have dairy goats.
When not milking her goats or studying the stars, Samantha's light pollution research has created an unexpected new challenge: navigating the media.
I have terrible imposter syndrome. Logically, I know this is completely ridiculous. I had CNN come to my farm and interview me. I had them drive out to this really dark site about an hour outside Regina, and we're watching the sky get darker, and there's like no satellites visible. And I was seriously doubting everything I had ever done. Just like, did I bring this news crew here for nothing? Did I make this up? Am I crazy? Like, and then finally it got dark enough and there were so many satellites, and it was, actually much worse than I expected. So it was gratifying but also terrible at the same time.
But it's worth it to bring attention to a cause she cares so much about.
Oh my gosh, this is actually really important to the entire world. Wow, right? That's been a pretty crazy thing to realize.
Like many good scientists, Samantha is less concerned about the answers than the questions that arise during the process.
I know that we're going to find wild things that nobody expects. I think that's a big misconception about science is, everybody thinks, eureka is the sound of science, but it's actually more, that's weird, right? The really exciting parts of science are finding the oddballs that you don't expect and then trying to explain them and realizing that you had everything wrong and now you need a new theory to explain everything.
Be careful how I say this. Some scientists are not comfortable with being wrong. They always feel like they need to be the expert in everything and have trouble taking advice from others. Sam and I are both not like that, and we're both willing to admit we don't know what the hell we're talking about or find that we're wrong on something and then reach out to the people that we need for help. I don't know of many other people that I've been able to work with that get along with immediately and function in exactly the same way.
Sam is really great to discuss science with, and she's often very current and up to date on sort of all the ongoing political issues related to science. And it's great to talk to her about a lot of the access issues and things like light pollution. And it's important to think about astronomy not only in the context of science, but in the context of culture and in the context of people outside the field and what they can get from astronomy and what astronomy should be providing to them. And I think Sam does a great job of reaching across that line to connect with the public.
Working with Sam has been a blast. It's a real treat. I will be happy to be Sam's collaborator for the rest of her career if she's willing to have me.
Oh, how pretty the sky is. I ought to go there on a rocket. It never comes down.
With all of the hard work, meticulous measurement, and data analysis that observational astronomy requires, does she still feel that same sense of awe that she did as a little girl dreaming about her space?
Oh, absolutely. I am so grateful that I live in a place where I can see the Milky Way from my back door. And I look at it every single chance that I get. When I go out to take care of the animals in the morning, it's totally dark, and I get a few minutes of just staring up at the sky and thinking about it. Sometimes I see satellites and I get kind of angry, but I try to ignore them and just look at the beautiful Milky Way behind it and think about who might be looking back at me. I still, despite all the school and all the research, that I still think about that every time I look up.
Thanks so much for joining us for another episode of Go Far Together. Check back here to learn more about the world-leading research being done here at the University of Regina. Be sure to like and follow this podcast and visit uregina.ca to learn more about the groundbreaking work at the University of Regina.